So, uh, welcome everyone. So, here we are going to discuss our to learn the new concepts which we in this pharmaceutical organic chemistry. Okay, so in the last some of the lectures we have is learned what is called this boiling point. What are the several properties of the molecules which may induce the polarity within the structure. So our observation says that polarity of the bonds induce the polarity of the molecule. So polarity of a bond is generally may induce the polarity within the molecule. And polarity of bond, that is because of the electronegativity difference in some of the atoms, such as carbon and hydrogen. So electronegativity difference is no. So they will not have any kind of polarity in themselves. But they will make a non-polar bond. But if we have difference in electronegativity, for example, if we have, let us say, oxygen and carbon, then both the oxygen and carbon are having difference in electronegativity. So because of this difference, oxygen and carbon will have some partial positive charge, partial negative charge. Okay, so friends, that's why I wish to just say that of the bond will exist discuss in the bonds of the molecules. Then this is going to induce the polarity within the molecule. Polarity we can calculate with the help of this, I mean to say, dipole moment, from whose name this dipole moment is known. The unit of the dipole moment is d by, that is abbreviated as capital D, symbolized as capital D. So dipole moment is a kind of additive direction. So, and that is a kind of which is having directional dependence. Means for we have seen some of the molecules such as oxygen, hydrogen, nitrogen, and carbon dioxide. So all these molecules have either the bonds which in themselves are non-polar, so they are having zero dipole moment. If there is a existence of difference in electronegativity, bonds may induce the polarity, but however, they are in exactly opposite direction. The directional dependence of these dipole moments, that is exactly opposite to each other. One is going in some, let us say, north, then other dipole moment is going into the west. So that way, it is counteracting one dipole moment is exactly cancelled by other dipole moment. So overall dipole moment of the molecule is zero. So this is also we have seen. But some molecules are having dipole moments, such as water. Oxygen is connected with two hydrogen atoms, and that is having some amount of dipole moment. Okay, because lone pairs which are present on the head of the oxygen, they also have some amount of dipole moment. Then we have seen ammonia. Another example of ammonia we have seen where NH3 is present, where nitrogen is having attachment with three hydrogens, and there is one lone pair on the head of oxygen. On oxygen, there is one lone pair. Because of this, also it possesses dipole moment. So we have shown the dipole moment with the help of arrow. In this arrow is always cut from the end. That is demarking the starting, and the head of the arrow that is always pointed out towards the more electronegative atom. Okay, so these are the concepts we have seen in these dipole moments. Okay, so then it comes to the question that What are the other properties of the molecules? So among other properties, we have seen this melting point. We have visited the definition of melting point. So if somebody asks what is melting point, then never ever define melting point is the temperature at which compound starts melting. This is a correct definition, but it is only 1% correct. According to me, it is not fully correct. It is not completely correct. The complete definition is that temperature at which external thermal energy is enough able to overcome the intracrystalline forces that hold the molecules together, that hold them in position. Perfect example for this we have seen is sodium chloride, where sodium ion is surrounded with chloride ions. Chloride ion is surrounded with sodium ions. That way, these lattices of the sodium chlorides are compactly arranged. And because of this, if we give the external thermal energy, then the intracrystalline forces which will be dissolved, which will be no more available. And because of this, a solid compound may convert into the liquid compound. Okay, so connecting this, we have seen that melting point of substance is basically a temperature, and we can record that using thermometer by setting certain devices using paraffin oil. So if we set up assembly for melting point, then in our lab we can perform this investigation. We can record the melting point of any solvent which we require. Then after that, today we are going to learn another new topic, what is called boiling point. Okay, so boiling point of the solvent, that is as similar as the melting point. So what is called boiling point? Simply, if I say what is the boiling point of water, a substance which is having, let us say, 100 degrees Celsius, boiling point. ये तो पढ़ के आए हो ना during your schooling. So temperature at which compound starts boiling, if you say like that, is called boiling point. And this definition is not perfect definition. Again, it is partially incomplete definition. Let us understand what happens during when a compound is boiled. I mean, basically, boiling point is for the liquids. Boiling point is not applicable to, let us say, solids. So solids will have boiling points, but if we have liquids, then liquids will have solids may have melting point, but if we have liquids, then liquids will have boiling points. What happens when we boil? Just like you are preparing one tea at 4 o'clock for you at your home, for yourself and for your family members. 4 baje ki chai. Okay. So how do you prepare that tea? We are taking water, putting it into some pot, and then we are adding the milk. We are adding the tea granules or sometimes tea leaves, depending upon the availability. And then we try to on the gas stove. Okay. So what is the process? The process is the increasing the temperature of water. So at this, basically whatever the water is there, it will start boiling at certain temperature. आप बहुत ही ज़्यादा गैस स्टोव full control कर दोगे fully, then it will start boiling. And under the boiling, it will from liquid phase, liquid water will get converted into the vapor form. And because of the high temperature, the solubility of tea granules will be higher in this tea which you are going to prepare. Okay, so that's why the tea will be sometimes it will be strong. जितना आप उसका गैस को जितना स्टव कंट्रोल में करोगे ना, if it is full, then सब maximum amount of tea granules will be dissolved in tea in the your medium water and as well as the milk. Okay? मीडियम करोगे, मॉडरेट गैस स्टव रखोगे, तो द टी विल बी मे बी moderate kind of tea. Sometimes it may be strong tea. ઘણા લોકોને હોય ને કે કડક ચા પીવી ગમે, ચા વધારે હોય તો જ ભાવે, નહીં તો ના. ઘણાને એવું હોય કે ખાંડ ઓછી હોય તો ભાવે. That depends from one person to other person. But if during this phenomena you might have observed the vapors are coming out. So this is a process. So boiling is a process. What happens actually? Each and every substance will have some amount of atmospheric pressure. If there is certain atmospheric pressure, likewise, 1 millimeter Hg is the atmospheric pressure, which is the pressure of surrounding. It is said that if we go to sea or beach, then whatever the pressure is there, that is considered as 1 atmospheric pressure. So this 1 atmosphere pressure at which all the things are vaporized. So when we are hitting our reaction water and milk, so at that time vapor pressure increases. Previously it was zero when it was in liquid form, but we are giving the energy through gas energy in the form of thermal heating, and vapor pressure will increase. It will go on increasing as we are providing the consistent amount of energy. At certain, the vapor pressure will be maximum. Itna maximum as equal to that of the atmospheric conditions. And thus, this substance is completely vaporized. It is not available in the form of liquid. So this is a phenomena of what is called boiling, where we are boiling the compounds. We are hitting the liquids to convert them into the vapor form. So let me show it to you how these things are possible. For example, if we have boiling point, if a substance is there, then we are taking it in a particular beaker. And then if we are, it is in a form of liquid, these liquids, if I can draw the circle, it will be more good. So these are the circles, like maybe like this. I'm drawing so many circles from this. Consider all these circles as some molecule. Okay, so there can be many molecules, but being a liquid, they are compactly arranged with each other, right? Molecules of liquid which are sometimes present in the always, and I'm sure with the help of these spheres. Okay, consider them as you may consider either. No issue with that, but they are compactly arranged. One is overlined with other. So this way, all of them are compactly arranged. It looks good. So all these are basically water molecules. Okay. So now, if we are giving some amount of energy, then that is in the form of thermal heating. So we are heating this. What is actually being converting here? Previously, it was in the form of liquid. Now this liquid is going to under conversion in the form of thermal heating. And because of this thermal heating, now it will be in the form of, let us say, some vapor form. How the vapor form will look like? We know that the entropy of gaseous molecules are maximum. Solids will have least entropy. Liquid will have entropy in between, and gaseous molecules will have entropy maximum. So this is the way that now what we'll have, gaseous molecules will look like this. जितने भी वहाँ पे थे वो all they will be away from each other, so that no further any kind of distance between them is much maximum. And according to law of thermodynamics, the entropy of all of these compounds, all of these molecules of, let us say, water, that will be highest. So I'm drawing them which are completely away from each other. And this already you might have seen that whenever if we are just burning some uh, candle, or let us say આપણે ઘરે જે અગરબત્તી કરીએ છીએ. Okay, so moment we are doing that, this smell, the fragrance will spread immediately into the atmosphere, into our surroundings. It is so because gaseous molecules are the one which are having highest amount of entropy. They will spread easily the matter or into the atmosphere. Okay, so that's why this is in a form of vapors. Okay, liquid upon heating is converted into the vapor form, and this way the you can see how they are having so much distance. If I say water, so water is a substance which is having boiling point, as you know, it is having boiling point of 100 degree Celsius. Okay, so water is having boiling point of 100 degrees Celsius. Then can be some other as well. There are so many other solvents which are having different boiling points. Let us say ethanol is having boiling point of 78 degrees Celsius. Then methanol is having about 50 degrees Celsius. Acid dichloroethane is that is having boiling point around 30 degrees Celsius. That is list as an organic solvent with list or this. If we have toluene, 110 degrees Celsius. If we have dimethyl sulfoxide, DMSO, so that is having boiling point 150, 160 degrees Celsius. Dimethyl formamide, boiling point is 150 degrees Celsius. These are the solvents which will have their specific amount of boiling point. And depending upon this, we can also characterize the substance as well. Okay. So this is a major concept which I wish to share with you. It is also applicable to so many other kinds of the substances as well. So friends, after this, another I hope the concepts of this boiling point is much clear. But if somebody asks you what is called boiling point, then never ever define that boiling point is a substance at which a boiling point is a temperature at which a compound, a liquid will start boiling. This is not the perfect definition. The perfect definition is, if you understand the concepts of boiling, perfect definition is it is a temperature at which the given liquid, the vapor pressure of the given liquid equals the atmospheric pressure. That temperature is termed as boiling point. Vapor pressure of a substance is equal to the atmospheric vapor pressure. And this you have already visited during your this chemistry में आपने वो thermodynamics में पढ़ा होगा, vapor pressure, depression, elevation of boiling point, etc. During this the water is having 100 degrees Celsius as a boiling point. Why? Let us say some other substance, dimethyl formamide point. 150 degrees Celsius. Why ethanol is having boiling point 78 degrees Celsius? So why they have this can be due to the bond formation. Several kinds of what is we used to call them as uh, forces which exist between the these forces either they may be intermolecular forces or the forces may be let us say intramolecular forces. If we say that intermolecular force, then intermolecular force is a force between the molecules, and intramolecular force is a force that is among the uh, within the molecule. So two types of the forces are known. What is called intermolecular force. Okay? So intermolecular force is a force that exist between the molecules. Inter का मतलब वही होता है, inter का meaning है it is between the molecules, among the molecules. Inter means between. The force between the molecule that is called as intermolecular forces. If we are told another kind of force, this is not the force just like air force or water force, police force, but this force is intramolecular force that exists in the so friends. What is called intra? Intra means is basically dictionary meaning of intra means within, means itself. So that way they are different. Intermolecular means which can exist between the molecules. Intramolecular means which can exist within the molecule. So within the molecule, if there is somehow kind of uh, interactions, so that is termed as intermolecular and intramolecular. Okay, so now I'm going to touch, let us say this, uh, basically this intermolecular forces. So some of there are two types of majorly intermolecular forces are available. One of the force that is called as this dipole-dipole interactions. Dipole-dipole interactions. This is a number one force which may exist within the molecule. You might be knowing already something what is called dipole-dipole forces, but I am showing you some of the highlights of this. So that is called intermolecular forces. Another kind of force after this that is called van der Waals force. Okay? So van der Waals force is a second type of the intermolecular forces that can exist between the molecules. Another type of the bond that is, let us say, hydrogen bond is also kind of interactions that can exist between the molecules. It is also possible within the molecule. I will show some of the structures where such interaction, hydrogen bond is also possible in the molecule, between the molecules. So that is a kind of common force. Then there can be also some other kind of force. We have seen covalent bond. So that is a kind of, although it is not a force, but it is a kind of bond. Then ionic bond, that is also kind of ionic interactions. So this is also possible. Then something what is called London forces, which are completely non-polar interactions devised by scientists. उसी के name से this is known as the London forces. Okay. So now first dipole-dipole interaction. What is called dipole-dipole interactions? As the name suggests, di and pole. So di means two and pole means ends. So it is having two poles. So that's why it is called as dipole. So, for example, if we have, let us say, a molecule, let us consider a simple this tabular shape as a, I'm drawing it as a tabular shape, or let me uh, erase this. So instead of doing this, I will be using some circle from this side. Let us say this one. Okay. So let me show as a sphere, this as a, some sphere as water molecule. Consider other and I will label it as OH. This is a water molecule. Consider this sphere as a water molecule and it is having two ends. One end is H, other end is OH. You know very well H is always positive and OH is always negative. H plus, OH minus. So with respect to that, this is a molecule which is having positive charge. So positive end will be present over here. Okay. And negative end will be present over here. H plus, OH minus. So this is a one dipole because it is having two poles, two ends, which are completely opposite. One is positive, other is negative. So that's why this is a dipole. But if we want to develop dipole-dipole interactions, there should be existence of other dipole. So let me draw one more dipole just similar to this. Now, one of the pole for this, assume it is hydrogen. Other pole for the same, assume it is OH. Right? So this will be positively charged being hydrogen and this will be negatively charged. H plus, OH minus. So this kind of interaction between I wish to say the interaction between this two here, OH minus and H plus, if it is visible, this interaction, all interactions, dipoles, that dipole, dipole interactions. Because this interaction is, although the molecule itself is neutral, we know water is a molecule having pH 7, that is a neutral molecule, but फिर भी it is having some amount of charges. H plus ion, OH minus ion, and that is because of the ionization, autoprotolysis of water, where the water undergo ionization with another molecule of water. It is not unknown to you. Okay, so that's why these ions are present in a water molecule and they are developing these dipoles. Dipole is also possible, for example, HCl, hydrochloric acid. Sorry, this is actually not the correct formula. Is possible with hydrogen fluoride, hydrogen bromide, hydrogen iodide, Hi, HF, HCl, HBr, water. These molecules have dipoles as present. Even we can have the more dipoles are also possible between one chlorine and other chlorine. Okay, where one chlorine will be negative, other chlorine will be positively charged. So these kinds of dipoles are also possible, but these dipoles exist, unka existence maybe their dipole moment will be less than that of. So these are the forces which is called dipole-dipole interactions. Okay, so hydrogen bonding is also possible. So that is another kind of one more that feature is there. Now let us go to another one. After this, we are going to learn about van der Waals force. What is called van der Waals force? So van der Waals force is the force which was given by a scientist whose name is van der Waals. And from his name, this molecule, this kind of forces are termed as van der Waals forces. What is this force? Van der Waals force is generally termed as non-polar molecule that exist between the non-polar molecules, such as methane, ethane, isopropane, butane. If we have polar molecule, then we can have hydrogen bond. We can have dipole-dipole interactions. But for non-polar molecules, are hold with each other through the van der Waals forces. But these interactions is much weak, is not strong. These interactions are weak. By giving only some amount of energy, we can break down, we can overcome van der Waals forces. It was devised by a German scientist, van der Waals, and from his name, this van der Waals forces are termed forces that exist between the I mean to say non-polar molecules. The sugar molecules sometimes they are they have these interactions. Okay, so van der Waals force is yeah. So this is a force which depends upon the distance of a molecule, distance between the molecules, between the non-polar molecules. Now let me show you how this van der Waals force can be there. For example, consider this as a non-polar molecule. Here is one molecule, this is another molecule. Okay. So the distance between these two molecules is in quite big. Consider they are far apart from each other. And because of this, they cannot interact. Okay. Now, it's with respect to this condition, if this sphere is one molecule and this another sphere is one molecule, so if they are closer, then van der Waals force between these two molecules is quite higher. They are now closer. Further, if distance is further, these two molecules are in closer proximity with each other. એકબીજાની સન્નિકટ છે, એકબીજાની નજીક છે. So in that case, van der Waals force is highest. I mean to say higher than the previous. वो दूर थे उससे अच्छा है, वो थोड़े नजदीक आए उससे भी अच्छा है, वो क्लोज आ गए. But this distance will be maximum. These two molecules are completely close with each other, and when it is said at this moment the distance will be, I mean to say, the magnitude of van der Waals force is maximum because they are in touch with each other. If the molecules are hold tightly to each other, in that condition, van der Waals force will be highest. Okay. So in how to define them scientifically? To define scientifically, we can claim that if the distance between the two molecules, if considering, let us say this is the center of this molecule, this is also the center of this molecule, I mean to say here, and if we, the distance between these two molecules is equal to the summation of the radius of these two molecules. બરાબર ને, જેમ બંનેનું વચ્ચેનું distance that is equal to the summation of their radius. That at that moment, van der Waals forces will be maximum. Okay, so here the molecules may not be spherical in nature, but we are assuming the molecules are spherical in nature. Just like we have never seen the God. Have any one of us have seen the God? I have never seen God. आप में से किसी ने देखा है तो they can approach me. Yes, I have seen the God. हनुमान जी, गणेश जी, अल्लाह, खुदा, जो भी God, I have seen him or her. Supreme power of the earth, supreme power of the I have seen. If somebody can claim, so it may be sir, किसी ने देखा होगा. I am not challenging, okay, but we are hypothesizing. हमने नहीं देखा है, मैंने अपनी लाइफ में नहीं देखा, but I am hypothesizing that Hanuman ji will be like this, having gada in his hand, or some Durga Ma, we will be having Trishul, Bhagwan Shankar, Lord Shankar will be having Trishul in his hand, which is his Lord Ganesha will have big trunk like an elephant. Okay, so we are assuming. I have never seen Lord Ganesha, but I am hypothesizing, etc., etc. So similarly, we have not seen the molecules. How the water molecule, a single water molecule. I am not saying have you ever seen the water. I am asking have you ever seen the single water molecule. So that is my question. So that's why here I am is a form of sphere. So वो मैंने predict किया है, imagine किया है. So this molecule or all the molecules has spherical in nature, circular in nature. So moment they are spherical, they will have certain. So Van der Waals was the first person. He told that if the molecules are closer with each other and the distance these two molecules is equal to the summation of the radius of these two molecules, then this radius is termed as van der Waals radius. Okay, so this terminology was given by these people called van der Waals radius. Van der Waals, yes. It is also called sometimes as van der Waals radii. Both the meanings are same, van der Waals radius or van der Waals radii. Okay, so the force will be maximum at this moment. Now let us go further. Let us try to increase the force between these two molecules by bringing even close to each apart. Here the force is maximum, but थोड़ा और नजदीक लाओ. जितना try to club them together. It will do. Now they will not have interactions, but they will start repulsions. After certain moment, if we try to bring them, they will have repulsions. और थोड़ा नजदीक लाने की कोशिश करो. So जितना भी हो सके उतना. Then in that case, this van der Waals radiation force will be reduced. So that way, if we there is a certain distance at which this force is maximum, but then उससे भी ज्यादा और close लाने की कोशिश करते हैं, तो they are having repulsion with each other. So here, let us say if we have, I mean to say attraction, then in that case, here it was basically attraction power was there. But in this case, here this power is, let us say, repulsion. Okay, so this way, this is possible. Attraction as well as repulsion. So here the force was I wish to say it was maximum, but here uh, maximum, but here it was the lowest one. Here van der Waals force the lowest. That way, this magnitude of van der Waals force is changed. When the molecules are apart from each other, this van der Waals force is zero. If they come closer, magnitude is higher. If they come closer, magnitude is further increasing. If they are in touch with each other, magnitude of van der Waals force is higher. फिर भी और close लाने की कोशिश करो, then they will have repulsion. More they go away from each other, the van der Waals force decreases. This is a force, kind of attractive force, which depends upon the distance of the molecule. Dipole-dipole force, that is also dependent upon the distance, but majorly due to the polarizability. Positive charge, negative charge. Non-polar one is the bond which does not, which is dependent upon, I mean to say, this non-polarization of the molecule. Okay, so this is a concept of van der Waals forces. After that, another concept which I wish to share in today's class, that is called hydrogen bond. Okay, so hydrogen bonds are the another concept that we want to learn today. A big hydrogen bond. What is called this hydrogen bonds? Already you have visited, but just I'm giving, just I'm trying to make your concept clear for this. Hydrogen bonds are the bonds which is in between the hydrogen. क्योंकि एक तो खुद का नाम तो है ना bond में, इसलिए it is a bond between hydrogen and electronegative atom. But this bond is not a covalent bond. This bond is not an ionic bond. This bond is not neither dipole-dipole interaction or van der Waals force. This is electrostatic forces. What is called electrostatic force? So let me just write down here. It is an electrostatic force. When the atoms are static, he will develop certain charge. He will make the bonds. For example, if we have water molecule, then let me draw water molecule over here. This oxygen of water is connected with further two hydrogens. So we cannot call this solid bonds as hydrogen bonds. We cannot call two OH bonds as a hydrogen bond because they are the covalent bond, which is formed by the sharing of electron. One electron from oxygen, one electron from hydrogen. So they are making a covalent bond, संयोजक bond, सहसंयोजक bond. That's why they are having a kind of covalent bond. But this oxygen is an atom which possesses, let us say over here, two electrons, one lone pairs. We previously also discussed. So this bond which will occur, hydrogen bond which will occur between the other hydrogen atom, that is through electronegative atom. And electronegative atom in our case, in the case of water itself, is oxygen. So this oxygen here, it is having one lone pair. So that will be making some electrostatic interactions with the hydrogen. Maybe this hydrogen belongs to also other water molecule. That is a kind of also friendship. Okay. So just like you people were in your, just say you are in LM College of Pharmacy, right? Your school friend, schoolmate may belongs to some, he or she may be also in Pharm D or B Pharm, or maybe in MBBS, but is there in some other college, let us say a BJ Medical College or some Sal Institute of Pharmacy or some Saurashtra University, wherever. But you are still in with him, his or her touch. Yes, our teachers have started online teaching, or our teachers are conducting this way, that way, etc., etc. So you are interacting. So that is a kind of your bonding between within the friends. So if a human being, we can have such interactions, molecules also possess such interactions. Although that interaction may not be strong, because आप अपने वो friend को हर दिन देख नहीं पाते हो. But हाँ, you may have some this kind of interaction, discussions. That is possible. So molecules are also having such kind of interactions, where electronegative oxygen atom is interacting with hydrogen of other water molecule. So similarly, here also this oxygen atom is interacting with the hydrogen of, I mean to say, if I consider this as another water molecule, so it is interacting with this way. But this interaction is, friends, this interaction is purely electrostatic. That is due to the difference in electron negativity. There is a difference in electronegativity of hydrogen and oxygen. I have given the sequence previously. Highest electronegativity is fluorine, then oxygen, then chlorine, then nitrogen, bromine, carbon, and hydrogen. So this electronegativity sequence is the inherent property of the elements. It is present there. Then this water molecule also, which is having one hydrogen bond, so that can have further interaction with oxygen of other water molecule. Previously, hydrogen was interacting with oxygen. Now, sorry, this oxygen was interacting with hydrogen, and here some other property, some other element is there, which is also showing somehow kind of this interaction. Okay, so here this is hydrogen. So water, as of now, it has made 3 hydrogen bonds. 2 हाइड्रोजन बॉन्ड तो ऑक्सीजन ने ही बना लिया, क्योंकि उसके पास 2 लोन पेयर था, और एक तो इसने बनाया. सो व्हाई नॉट दिस वन? इसने क्या पाप किया है कि ये भी तो बना सकता है हाइड्रोजन बॉन्ड. यस, दिस इज आल्सो कैन मेक 1 हाइड्रोजन बॉन्ड. Okay, so if somebody asks that a single water molecule can make how many hydrogen bonds, the answer will be 4. A single water molecule can make 4 hydrogen bonds. Okay. So this way, they are connected with each other. This hydrogen is, let us say, this water molecule is connected with hydrogen bonds. So similarly, this water molecule is also further connected with 4 hydrogen bonds. इसके भी 4 hydrogen bond है, इसके भी 4 है, इसके भी 4 है. So you can imagine the solvent water is made up of how many numbers of hydrogen bonds? 1 mole of the substance contains 6.023 into 10 raised to 23 number of molecules. 1 mole of water is equal to 18 gram. 18 ग्राम पानी में 1 मोल मतलब है 6.023 into 10 raised to 23 number of water molecules है. 18 ग्राम पानी में 18 gram, 18 gram. And 1 water molecule is making 4 hydrogen bonds, then 6.023 into 10 raised to 23 water molecules can make how many hydrogen bonds? Maybe 24 into 10 raised to 23 से भी ज़्यादा. You understand? 1 gram of the substance contains 6.023 into 10 raised to 23 number of water molecules according to Avogadro number, not according to me, but it is according to Avogadro number. So water is having plenty of hydrogen bonds. तो इसीलिए this water is having highest boiling point, 100 degrees Celsius. Dichloroethane, which is non-polar, and boiling point is simply 30 degrees Celsius. This water is also having highest dielectric constant. Water melting point 0 degrees Celsius. This dielectric constant is far beyond 98. Boiling point 100 degrees Celsius. Molecular weight 18. And formula this H2O. So this way it is having so many other properties. Viscosity is also there that we can calculate in poise or centipoise. Right? So my concern is to focus on hydrogen bond. Single water molecule can make 4 hydrogen bonds. Similarly, you can imagine a molecule of HF can make 2 or 3 hydrogen bonds, 1, 2 or 3. A single HF molecule can make 2 hydrogen bonds. एक हाइड्रोजन बनाएगा HF का और दूसरा फ्लोरीन बनाएगा. The 2 hydrogen bonds. Ammonia, NH3, how many hydrogen bonds? Total 4. 3 hydrogen bonds by hydrogen itself and 1 hydrogen by nitrogen, hydrogen bond. Because ammonia, if I draw the structure of ammonia, then ammonia is also having nitrogen here. That is connected with 3 nitrogens, 3 hydrogens. Likewise, this hydrogen, this will also make 1 hydrogen bond. This will also make 1 hydrogen bond. This is third. And here there is presence of 1 lone pair on the head of oxygen. Okay, friends, the hydrogen bonds can be formed. This is number 1. 1 hydrogen bond. This can be another hydrogen bond. And this can be another hydrogen bond. Okay, so this way ammonia can also make 4 hydrogen bonds, just like water. See, also you need to consider electron lone pair. Nitrogen के पास एक ही lone pair है, oxygen के पास 2 है. All the hybridization is sp3 in both the cases. Okay, so with this we will stop up to here, and if you have in the coming class we will discuss from this onwards from our topic of this hydrogen bonding. Thank you everyone. Thank you so much.